All right, hello everyone. We're going to look at a Delta Math assignment. The assignment is called Surface Area from a Net. And what we're going to be doing here is we're going to be taking an object that was originally a three-dimensional object. So for this one, I want you to imagine these two triangles were folded straight up. Then this gets folded up so that these two sides meet. And then this gets folded up along the diagonal so that this top side meets the top of that, and this side runs along these. So it ends up being what they call a triangular prism. So with these types of problems, a shape gets unfolded like a cardboard package would. If you've got a cardboard box and you undo all the tape and fold everything outwards. So that's what we're going to do here. Now, the skills you'll use are skills. You can see problems like this in a geometry class, but these are skills you should learn before like high school level geometry. And this is just finding the area of a square, a rectangle, and of a triangle. So let's take a rectangle. In a square, you're going to do the same stuff. Square is just easier because everything's the same. But you're just going to take the width and the height and multiply them. 7 times 4 equals 28. Okay, that's all you got to do to find the area. Now, you can memorize the equation for a triangle. The equation is going to be one half base times height. But I would rather you, instead of memorizing some equation, I want you to understand why this works. So I'm going to make a triangle right here. And let's say the base is 7 and the height is 4. Now, instead of just memorizing this, I want you to see we have 7 and 4. Over here we had 7 and 4. Notice in order to make this triangle, you're literally just drawing a diagonal from here up to there. So that's all you're doing. You're drawing a diagonal through it, which essentially just cuts it in half. So if 7 times 4 was 28, and to make it into a triangle, you're cutting it in half, just take half of 28, which would be 14. And so our answer there is 14. Pretty simple. And so when we do this, just remember that multiply the sides if you're trying to get the area of a rectangle. If you want the area of a triangle, do the exact same thing. Just do it and then cut it in half, okay? So let's move on to a problem. All right, so I'm going to look at this problem. So we see that we have a box up here, and we'll be able to find that area pretty easily. You see that? We'll just do 14 times 8. That's going to be simple. We have a triangle right here, and we have the base, and we have the height, 8 and 12. We'll just multiply that, cut it in half. Now, over here, it's the exact same triangle. One thing I should point out that helps in doing these problems where they give you some sides but not every side is that whenever you have a rectangle, a property of rectangles is that the sides across from each other are always the same. So if that side is 2, the side across from it has to be 2. Okay, if this side on top is 5, the side below it has to be 5. Okay, you can just use that to fill in the blanks when you're doing these problems. So when you have this problem right here, we can take this 12 and assume it's over here. And then because this side is 8 and it runs along that, making this 8, you see this is also 8, and this would be 8. Because when you fold them up, they're going to go right along each other. So this is the exact same triangle. We already know this side is 12. To do this rectangle right here, we see this is 14. So this side must also be 14. And then lastly, this side is 14.42. And we know this side is 14. So let me show you what this is going to look like. I'm just going to be able to fill in the blanks. So first rectangle on top. They tell us it's 14 and 8. So I'll go ahead and just do that right now. 14 times 8. And we get 112. And then the next rectangle, okay, you see I'm just taking what they're doing, but to make it easier, I'm drawing it so I can focus on one shape at a time. So they already told me that this side was 12. That side is 12. Because that side is 14, the side over here must also be 14. Okay, so we're just going to do 14 times 12. And we get 168. Okay, let's keep going. We have a triangle over here. And we have a triangle over here. And we know that on the triangles, it's 8. And then this side is 12. So remember, to find a triangle, just multiply the two sides. 8 times 12. 8 times 12, 96. And then just divide it by 2, because you take 1/2 base times height, or half of whatever it would have been if it was a rectangle. So we get 48. And we know that this triangle over here is exactly the same. I know it's getting where we got all sorts of numbers all over the place between these sides and the actual areas. And then last, we take the bottom, and it's 14.42. And because that's 14, that must also be 14. So we're just going to do 14 times 14.42, and we get 201.88. So you see, if I go back and get rid of this so you can see it, they only give you a couple sides here, but you can project what the other sides will be, and you can find the area of 1, 2, 3, 4, 5 different shapes. And then to find the surface area of the whole thing, you just add all those together. Okay, so I'll end up using this, it'll be 112. Plus this one is 48. Plus that one right there is 168. Plus this one right here is 48. Plus 201.88. So this isn't the cleanest looking thing, but I'll write it down below. Plus 201.88. And then we'll just add all of those together. So we'll just do 112 plus 48 plus 168 plus 48 plus 201.88. And we get 577.88. So let's go ahead and enter that. 577.88. And it's happy with us. So let's move on to another problem. Okay, so here, this is probably going to feel easy compared to what we just did. Let me erase this so we can get a fresh start. So in this case, you have a square in the middle. So 3.8 and 3.8, 3.8, 3.8. All of these are 3.8. And then, because it's a square pyramid. So I'll just do that right now in the middle. So it's just going to be in the middle before I do anything else. It's just 3.8 times 3.8. So the middle is 14.44. Circled it so we won't mix that up with what the sides are. And then right here, we have a triangle, and they made it clear that they're talking about the height of the triangle, not one of these sides. And the height is 3.7. So the height is 3.7. And if the height right here is 3.7, and we know all the sides are 38, this side over here is also going to be 38. And so we're just going to end up doing, I've been saying 38. It's 3.8. Excuse me on that one. But so we'll just do 3.8 times 3.7. But when it's a triangle, what do? You cut it in half. So for this, we'll just do 3.8 times 3.7. Then divide it by 2 because we cut it in half. And we get 7.03. So when I'm doing it right here, 7.03. There's another triangle over here. It's going to be the exact same calculations. No reason to redo it. 7.03. And then there's another one right here. And then we're just going to add all of them together. So it's 7.03 four times. So let's just do 4 times 7.03. So all four triangles make 28.12. Right? I did that by doing 7.03 four times. You get 28.12. And then add the square, which is 14.44. So on here, I'll do plus 14.44, and we get 42.56. All right, so let's go ahead and enter this here. And there we go. Let me do one more problem, and then that'll be it. Okay, so we have a toy box. Oh, this one's nice. It's just a whole bunch of rectangles or squares. There's no triangles to deal with. So let me go ahead and draw what we have here. So it's going to have square on the left. Okay, so all they tell us right here, it's a rectangular prism with an open top. The diagram below shows the toy box in the, okay. And we know that we have 8 meters right here. We have 6 meters right here. And then down here it's 15. Okay, so when this thing folds up and this thing folds up, then this side is going to run along that side. So if this is 6, then that also has to be 6 right there, right? When these, imagine when they fold up, they'll be running along, they'll fold up and they'll make a corner, okay? If that's 6, then this over here has to be 6. And then since they fold on the corner, then this right here must be 6. Okay? If that's 8, we have a bunch of rectangles, so then this is going to be 8. I'm not going to write the meter just for the sake of space. All those sides are going to be 8. And then I want you to see that this is going to fold up. Right? This right here is going to fold up along that. So then this part right here is going to be folded all the way across the top. So what that means is when you fold this up, this side right here will be on top. This corner will meet, so this side folds up so that this side makes a corner with this side, and then this is going to flop across the top. So that means this length from here over to here is going to run along this. So if this down here is 15, then this also has to be 15. And then again, with rectangles, if this is 15, then this right here has to be 15. Now we have everything we need. So let's do this one first. 8 and 6. 8 times 6. 48. Okay, let's do this one right here. 8 times 15. 120. Okay, let's do this right here. 6 times 15. 90. Let's do this right here. 8 times 6. It's across from this one. They're across from each other, so they're the same size, which makes sense. 8 times 6 gives me 48. And then right here, 15 times 8. This is going to look familiar. 120. Which makes sense because this little rectangle right here of 120 is on the bottom. This is the piece that folds on the top. So it makes sense. So we have 48. So I'll write this right here, 48 plus 120 plus another 48 plus another 120 plus another 90. You get 426. So this one was a bit different because you see they told me this side down on bottom, and I had to realize that when this thing folds up, this is going to run alongside. This probably finding the missing sides was harder, but the calculations were easier because there's a bunch of rectangles. So that's the kind of thing you do. All right. So I hope that you found this helpful. If you have questions and you're currently a student of mine, please email me. If not, you could ask anything in the comments. Or if you need videos of any other type of math, just let me know and I'll make it for you.